Okay, well, I'll say it again. I don't know whether I'm really retired. I don't think I am. I mean, I'm still accepting work if any work comes my way, and I might even go out and look for it. But I'm not doing very much paid work at the moment, and yet my time seems to be just as full with various things,
Okay.
including conference presentations and podcasts and interviews and so on. So,
So welcome back, by the way. So we are recording,
sorry,
and
sorry, yeah,
and the first time we started actually with the guest. Usually, I say hello, Morris.
yeah,
Uh,
sure. Go ahead, go ahead. Let's do that.
yeah, and what I notice right now that a young man, a Scottish man, right? Scotland.
Go on.
Y-
Hang on a second. Why do I want picture in picture? Never mind. Sorry, I beg your pardon.
Yeah.
Sorry,
What I said. How is possible that a young Scottish? You are from Scotland, right?
I'm not from Scotland, but I kind of am. I've been living here for such a long time that I consider myself
Yeah.
a native.
So semi-Scottish, a
Semi.
gentleman.
Oh no, 3/4 at least. Go on.
Okay. Gentleman, a young, is
Oh, yeah.
about to retiring. So it seems like with I don't know 30 years, and you are retiring.
Maybe a little bit more than that. But young people nowadays have these targets that they're going to retire at 30 or 40 or something like that. And I just think I'm trying to catch up with that a little late in the day. I mean,
Okay.
I won't see 30 again, and I won't see 40 again, but I can still try.
Do you think this is a good target to have? Because what do you do then, right? So let's say you do something what you like,
Yeah.
and then you are 30, and they're retiring. Now what? You are
Well,
spend your time on the beaches, or what's the plan then? You know?
well, that depends on them. I mean, I would. So I actually just now for the first time, I think for the first time in many years, I actually turned down some paying work
Hmm.
in September simply because I felt like I had so many other things to do that I
Hmm.
had to turn the work away. I would have been doing this work for interest, but also for money. So you've got to ask then if you're only doing the work for money, you must have something else. I mean, for me, you must have something else that you really want to do. I mean, for me, like life isn't the rest of the life I have isn't just an absence of work.
Hmm.
It's things that it's a kind of positive pressure. It's things that I want to do.
Exactly.
So I don't know what these people want to do who are retiring at 30. I mean, maybe they really want to um, work on making the world a better place, or on learning a completely new skill, or on I don't know. I mean, people typically they say traveling, but
Hmm.
traveling can encompass a lot of things. Maybe it's just taking your own troubles to a different place and
Hmm.
just looking at them there. I certainly wouldn't. I mean, for me, I can't imagine a retirement that would just be lying on a beach. That's not my
I
personality.
couldn't even imagine vacations doing that, you know. So after one day, maybe, and then I would say, okay, what's going on here? This is like a jail on the beach, you know.
For me, it is. I literally can't spend an afternoon on a beach. I'm that bad.
You cannot read because it's too bright. You can maybe, you know, enjoy the view for a few minutes, and everything is full of sand, you know, hot.
Yes, yes. Of course, that does also say something about you, about us, about me in particular as well. In that it's not great to constantly need activity and distraction. So to, I kind of admire these people who go to retreats, and sometimes the discipline in these retreats and the more extreme ones is you just have to sit and meditate
Hmm.
for hours on end, and I do admire that, and I actually am working towards that. I mean, I do something that people call meditation. I mean, that seems like a big word for it to me. And to manage 15 or 30 minutes of that, for me, that's quite hard work, and I think that's something to practice.
But what about taking to take a walk? 3 hours walk on the beach, for instance, right? So this is like you are walking, and this is a different story. I
Yes,
mean, yeah.
that's a different story. Yes, I mean but then again, nowadays, quite often when I'm out for a walk, I'll be listening to a podcast or to a
Mhm.
play or to a book, and again, I'm distracting my mind, and I feel like that's. that's not always positive. I mean, it would be very good to just walk and just be there and be present in the moment. That,
Yeah.
that's a great skill, I think.
What I missing, I don't know how to call it, their boredom. If you are really bored and the
Yeah.
time is just flows slowly. So in my case, everything is exciting and everything happens too fast. So it would be actually very cool stuff, just to get bored.
I
But
think
if
absolutely, absolutely.
Yeah, and even if I sit on the beach, and it still flows too fast. So I have to do something really boring, maybe start Python programming or something like this, right? So this could maybe this would help me, but right now it's like everything is fine except the time flies.
Yeah.
Um, Surprise for you! I have here something you see your
Oh
book.
yeah. Oh yes. I recognize that. It's a book.
Java Generics and Collections, Fundamentals and Recommended Practices. I took a look. I couldn't read it completely because it was quite a story. So what happened is I ordered it almost immediately and didn't came for weeks. And then it was released and still I had to wait. And then I got a big box from DHL. And it says like, I don't know what they say, like the packaging was damaged or whatever, but the book is fine. And they repackaged the package in another package. And this took like 2 weeks, and then finally I got your book and it's great. So I
Well,
took a look.
I hope it was worth all that trouble and
So
repackaging.
I would say this was the most adventurous order of a book, and from O'Reilly actually, because I think I was one of the first who ordered Java books on Amazon. I remember because it was the Java in a Nutshell, one of the first book. So I bought maybe 1996 or something like this. Was also beginnings of Amazon, and and it always worked. And in your book, this was really 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 adventure. But I like the book. I like how it's laid out. And today we would like to talk about collections, right?
Right.
So and I thought how to tackle that. And what's always interested me, because maybe you had the same thoughts if you started to write a book. So how to structure such a thing? Because a collection, if you think about the collections, uh, as I heard about collections at the beginning of Java, I immediately thought about arrays, back then vectors, right? Something like vector, but more sophisticated, is something like hash table, a little bit more sophisticated, and I would be happy. But collections are far more than that. And how you started that is actually similar to what I will do. You started with the collection interface. So it's like, this is the super interface, like the object of all collections. And then, interestingly, sequence collections, and then it goes on with sets, queues, lists, maps, and utilities like collections class. And what I really appreciate is guidance on using Java Collections Framework with some best practices or guides. And what I like is the best is avoid dynamic domain models, which is also my opinion. Just write expressive classes. And so what is your mental model regarding collections? So how you started the book and what was the idea, or maybe if you also started with JDK 1.0, so we had a vector and we had the hash table, and then collections happened. So what was your mental model, if you remember? So what will happen? It's like we get vector on steroids, or what was your expectation of the entire thing?
What you mean when Java 2 first came out? I don't think at that time that I was at all focused on collections. I think I greatly underestimated the complexity of the whole issue, and really until I came to write the book, it's quite a few years later. I mean, I knew about data structures
Mm-hmm.
from my academic background, but I didn't think that for example, there are innumerable graph algorithms and so on. It's the data structures and the theory of hashing algorithms and so on. I knew vaguely about these things, but I didn't realize how. I think I didn't realize what a prominent place they would have in understanding how to program in Java in practice. I mean,
Mm-hmm.
I thought, well, like I probably thought, well, one hash table is pretty much like another hash table, and linked lists are all absolutely fine. Like linked
Mm-hmm.
data structures are interesting, but only in order to implement graph algorithms and so forth. So I think I probably underestimated the whole topic a
Yeah.
great deal, and the question about my mental models is probably not very, very
Mhm.
important.
Same here. And for me, it was a bit different because I was asked by many companies to evaluate it back then, different commercial collection frameworks. It was JDK 1.1 time. They had the need for that. And I was amazed because they are completely different concepts. What I also remember, there was one framework with bags, bag, and
Yeah,
which
yeah.
is, and didn't back then, I just had, not like academic background. I studied computer science, but it's not like I studied data structures. So for me, it was a little bit over-engineered back then, everything, because I just use hash table and I was happy, right? And vector as well. And so you mentioned academic background. So what are the typical data structures? So if you so there are arrays, lists, and so forth. So what would be the essential data structures from regardless of programming language? So what do you say?
Well, I guess they're arrays.
Mm-hmm.
They're arrays. They are linked data structures. I mean,
Mm-hmm.
in general,
Mm-hmm.
obviously trees are a specialized variety of those. But then
Mm-hmm.
you've also got graphs in general.
Mm-hmm.
An important subset of those are acyclic graphs
Mm-hmm.
that are useful for a lot of problems, and hash structures.
Mm-hmm.
I think those are the main data structures I can immediately think of.
Sets, maybe, right?
Well, yeah. I mean, actually, so sets are really. I think sets are quite problematic
Mm-hmm.
because I mean, I was talking about implementations there. I
Mm-hmm.
think really.
Mm-hmm.
I mean, how are things implemented? Um, Sets are not an implementation. So sets are a kind of mathematical abstraction which are imposed on top of the limitations of computing science, and it's
Mm-hmm.
impossible to get a um, uh, to get a consistent. Well, it's not useful. I think to say. I think it'd be true to say that it's not actually useful to get a and also not possible to get a mathematically pure model of sets
Mm-hmm.
realized in an actual implementation. And the Java implementation.
Except maybe sets of numbers, right? If you have sets of integers, it would be pure, no? Because the hash is the value itself. So if I would create a set of integers, then it should be pure, right?
Yeah, but yeah, well, yes. I guess so. You could, yeah, you could say that they're never going to be infinite, which obviously is a kind of
Mm-hmm.
the model, or arbitrarily large, which
Mm-hmm.
is the model of sets. I guess you could implement. No, I mean, obviously in a finite computer you can't implement an arbitrarily large
Mm-hmm.
set.
Mm-hmm.
Um, so yeah, that's true. But once you come down to um, what we have in Java are things that we call sets, and they are sets after a fashion, definitely, that behave differently from the mathematical abstraction of sets, and they're really useful. And obviously,
How differently? Just what's the
well,
difference?
so an example is navigable set,
Mm-hmm.
or sorted set,
Mm-hmm.
and that's significantly different because it has a different equivalence relation from the equivalence relation for say
Mm-hmm.
hash set.
Mm-hmm.
The in a navigable set, the equivalence relation, that is to say, when two things are regarded as equal, that's defined by the comparator, or
Mm-hmm.
the comparison algorithm. Let's say, for the set, and that means you get some very weird results if you try and make that set interoperate with a hash map, a
Mm-hmm.
hash set. Sorry,
Mm-hmm.
so so the implementation is already a long way away from the mathematical abstraction.
Mm-hmm.
For example, equality isn't commutative any longer, as
Mm-hmm.
as a for instance.
Mm-hmm.
Um, and and quite often to get what you would expect to be the mathematically pure operations is computationally not feasible, and so you take shortcuts, and those
Mm-hmm.
can also give very peculiar results. We're doing a talk about this. Stuart and I are doing a talk about this at Devox Belgium.
Yeah, very good. So I will try to attend because your talks are always nice. So I really enjoyed the last one with Jose, and yeah, it was really nice. So as I told you, it reminds me on the the how it's called, the English Gentleman is the Top Gear, the old one, like as like just nice conversations between experienced people about the topic. So yeah.
A Top Gear was a comparison I never went to look for. You see me as a kind of Jeremy Clarkson of the Java world. No, thanks.
Hard to tell, either you or Jose, one of you, but it's not like because there was a nice conversation between you. There was like back and forth. I think this was about streams, right? This was a talk about streams.
Yes.
And I really enjoyed that, and because it was a nice conversation about a deeper topic. And yeah, okay, this Top Gear is. I don't care about cars, but what I saw some episodes, and this was like because they had nice conversations, funny conversation, which I enjoyed, and I didn't care about cars at all, but I just like how they interact with each other. It was fun.
Yes, I've recently taken to doing a lot more joint presentations with friends, exactly because I think it's a lot more interesting, exactly because of this. A conversation between people who actually like one another and can. Also, audiences like it if you tease one another a little.
Yeah, exactly. This is this teasing. This is what I like, and because it is a friendly teasing, it's fun, right? So, and this is like you can only do this with friends. I always rejected joint presentations because I never prepare actually, and if someone will count on me, it will be a disaster, because my presentation is more like, oh, I did this in last project, so let's talk about that. And in the airplane, I created the agenda and then I talk about that. So you could never rely what I say, which will never work. So this is like, yeah. But I enjoyed.
Actually, a joint presentation imposes a discipline on you, which is actually quite healthy.
Exactly. Yeah. But I'm not disciplined speaker. That's the problem. Yeah. Perfect. So could you maybe summarize, if you can, the mathematical definition of sets? What is the definition?
It's a collection in which order is not significant and there are no duplicates.
This is very simple. You're right. Most of the sets are actually.
Sorry, that's actually an abbreviated, in a very abbreviated form of it. If you look at the, if you look for the strict mathematical definition, that it's defined by something called Peano's axioms. Although there are different kinds of set theory.
Wow.
The classical kind are Peano's axioms, which I haven't thought about for years. But let's have a look. I think there's, as far as I remember, there's 8 of them. Let me find
piano, like the instrument.
Like the instrument, but with an E instead of an I. And Piano was an Italian mathematician. And 5 rules. I beg your pardon. So this shows how long it is since I thought of it. So this is Peano's axioms. I beg your pardon. These are Peano's axioms for the natural numbers, not for sets. What are the axioms of set theory? I'm sure
you see.
Axioms.
My podcast always, challenges the guests, and this is always memory intensive. So
this is so Zermelo-Fraenkel axiom ZF. That's right. These are the ones I was thinking of. I just remember the name wrong. So they are the axiom of extensionality. 2 sets are equal if they have the same elements. The axiom of regularity. Every non-empty set contains a member. Every non-empty set X contains a member Y such that X and Y are disjoint sets. In other words, sets can't be infinitely recursive. There's an axiom of pairing. If X and Y are sets, then there exists a set which contains X and Y as elements, for example. So in other words, intersection. You can intersect sets, and so on. There's an axiom of intersection, an axiom of union. And there's an axiom of replacement, which is roughly mapping over sets. So at one time, I actually made an attempt. This is going back many years to a kind of disaster in my life. I made an attempt to match up a computational implementation of sets, a real implementation of sets, with the ZF axioms. And it's actually remarkably difficult to do. I mean, it's really.
This would be a good talk for you.
Unfortunately,
the attempt to implement,
for me, because it was my first real disaster.
But you don't, show that it works. So how challenging it actually is will be also interesting.
Who would want?
Yeah, I will attend. So if I'm,
I would have an audience of one. I'll have to make sure it's.
I will be in the middle, and with closed lid on my laptop, so I will really listen. Yeah.
That would, it would be quite interesting to do, because I mean, it does strike me that in talking to Stuart about about the implementation of sets and about the paradoxes that we come across in our in the set implementations in the collections framework. For example, the fact that equality between hash sets and navigable sets are non equality is non-commutative, which is like really disturbing and kind of and very difficult to work with. We're not founding our thoughts about this and our conclusions. We're not founding it on ZF set theory or anything as rigorous as that. We're looking at it and we're saying, well, this doesn't seem to work, and the specification clearly makes some incorrect assertions, and we need to sort this out, and it's a bit empirical.
Okay. Yeah, super nice. So and in the set you have one very interesting one, copy and write array set, and I used it in the past for concurrent programming a lot. So you also find it interesting and useful?
Well, it certainly can be useful. I mean, people talk about it for some reason, I'm not sure why, as though it was something very obscure, but I don't think it is particularly obscure. And I think the use case for it is really obvious. It's a structure that copies that makes its read operations extremely efficient, because you're always reading from a snapshot. So there's no requirement. The actual set that you read from is always immutable. So there's no requirement for mutual exclusion of read operations, and they can be highly concurrent. But the price that you pay for this is every time there's a write operation, it has to take a copy of the complete set.
So the old readers see the old snapshots, and new readers will see the new snapshot, right? So it's like
that's right. The old readers continue to work on the old snapshot, and any new reader will read from the new one. So it's a very useful and efficient data structure, provided you have many more read operations than write operations.
And there's another one which is similar, concurrent skip list set.
Which it's interesting that although I described that, I very rarely come across anybody who's using it.
And I think I use this one for concurrent programming because I found the copy and write array set first. But the concurrent skip list set, it is a concurrent data structure, similar to concurrent hash map, I think. So
no, it's nearer to being it's more like a tree.
Yes, sure. But you have a hash map which is not thread safe, and you have concurrent hash map which is thread safe, and it's the same for hash set is not thread safe, and the concurrent skip list set is thread safe. So similar, how to call it, quality to concurrent hash map, not the implementation, rather than
essentially in the same kind of way as concurrent hash map is a hash structure that is thread safe. Concurrent skip list is a tree structure that is thread safe. And it's the only one. I mean, it's the only way. You can't make a tree, the classical tree. You can't make that thread safe. So concurrent skip list. A skip list is the only way that you can do that. But for some reason, it gets very little used, and most people regard it as very obscure.
And why? I mean, how it works? You remember that?
So I mean, there's a diagram in here which I kind of remember, but let me have it.
This is the page 203. We are talking about the book, and what's interesting, what interests me more is just about skip list. Why the name skip list? This is interesting.
Okay, so let me
page 203 in the great book Java Generics and Collections.
Yeah, that great book. Just give me a moment. So why is it called a skip list? It's called a skip list because, well, I guess so. A skip list simulates the behavior of a tree, but the way that it does it is to have a series of parallel linked lists, and these linked lists contain kind of randomly chosen elements from the base list. So there is a linked list at the bottom level of this series of linked lists, which you can think of as being stacked. At the bottom level is every element of the set. But of course, to access an element via linked list is clearly going to be very slow. So above the base level is a linked list which contains parallel elements. It has this something like, let's say, a randomly chosen selection, a subset of the base set.
So what it means is the skip list is called skip list because it's able, if it searches, can really search fast, because it skips under it skips over sublists, right? So it doesn't have to read everything; it just skips
absolutely
portions.
It's a way of finding. I should have said, by the way, to start off with, that these are for ordered things. So this is very important. So the base list must be ordered. Above it is a more sparse copy of the base list. And supposing you want to find an element, in, say, I don't know, 3/4 of the way down the base list, what you'll do is you'll walk along one of the higher lists, but you've got fewer traverses to make because they're more sparse. When you find that you've gone too far in one of the higher lists, you drop down to a lower one, and you search along that. But again, it's going to be increasingly less sparse as you go down this stack of lists. But overall, what you'll find is that roughly speaking, the number of traverses you have to make will be equal to the number overall. It's the algorithmic order is the same as that of searching a tree. I hope
exactly. Yeah. I was just curious about a skip, and as you explained
the skip. You're skipping.
Yeah.
So if you want to find an element that's, say, 3/4 of the way along the list, then let's imagine that your first stop is one of these lists, a higher list that has an element, like as in the illustration in the book, level 2 in the illustration in the book, has a single element in it halfway along the list. So you search, so a single traverse will take you to that halfway element. You skipped over the whole of the first half of the list, and you find you still haven't gone too far. So then you'll drop down to but the next one will take you too far. So you drop down to the list below, and then you'll skip over a number of elements in the bottom list until again you've gone too far, and then you drop down again.
And yeah, exactly. What I'm searching, I'm pretty sure I used that extensively, and what I found is a reference 10 years ago, because I implemented a very thin executor service-based framework, and I think I used the concurrent skip list inside, just to omit the hassle with concurrent programming. I just could use the data structure, which is mostly consistent, like concurrent hash map, and this is why I use that. And I always use the concurrent skip list, concurrent hash map, and from time to time copy and write array list. So the array list, array set. What was the name? Forgot about that.
Well, there's both of those.
Yeah, and the question is now when to use the skip list, and when it's better to use the copy and write set. So I understand copy and write array set is not a good idea if you write a lot and read a little, because there's lots of overhead. So what are if you remember, the disadvantages of skip list?
Well, it's suitable. It's only suitable if what you're wanting is an ordered. I mean, it's an implementation of navigable set, of concurrent navigable set. I don't know what makes it so unpopular.
So what it means is, maybe if you have already an ordered list, then copy the concurrent skip list provide you better performance. But if you have unordered set, I mean, this copy and write set is
then it carries a huge overhead compared to concurrent. The set that you get from concurrent hash map. That would be what I would do. There's a new set from Map, method, which will give you the corresponding set token.
Yeah, this is also a nice trick, right? You have a map, and you can ask the hash map, and you get set back, which is crazy. So this is actually a challenge to find this, right? So this is like
it's not completely obvious. I mean, it would be completely obvious if you understood that everywhere in the in the collections framework, maps and sets are very closely related. So essentially, sets are just are just maps, but they every element in they're maps in which every element maps to a constant value. So basically, a set is a map in which you only care whether the keys are present.
So we already.
So from that it follows that it's kind of obvious that they would just give you this way of just getting a set implementation. There's just no trouble to doing that. Very often the set implementations are just very thin wrappers around maps.
Yeah, but still, I would provide maybe another way, like hash maps dot like collection utility, or you know what I mean? Not you just picking from the. We have collections and arrays. Maybe introduce a factory interface, which will create just a set for you, right? Because it will be more obvious. Because asking hash map to get a set, you have to know already a lot.
You're thinking about something. Supposing you might have something like a factory interface, which would be it should a factory method. It should be on the interface. Well, there isn't a concurrent set interface, and perhaps that's the reason why we don't have a. You could put. I mean, you could put it anywhere. You could put it on the
collections, for instance. To my first attempt, collections. This is what I would search first. Dot concurrent set or whatever. Why not?
Yeah, I don't think the collections class. I don't think there's
or sets. Sets dot a new sets interface factory sets.
Let me have a look at the collections class API.
And collections, not collection, right?
Of course, I understand that. Let's get a modern one. Let's say 24. Collections.
Almost 25 now. Next we have.
Yeah, I would just. So the problem about something that they always face as a problem with the collections framework is making things findable and making things and also ideally keeping the API small. So I think that so I'm looking at the collections class has this method new set from map, and it takes a map, and I think that I'm pretty sure the thinking would be, well, rather than having, I mean, this is indeed kind of a factory method, isn't it?
Yeah.
Yeah. This is sort of quite like the factory method that you want, except that it's not new concurrent set from map, right? But what they're going to say is. That rather than proliferate, rather than have several versions of that method, let's just take the properties of the map that it's being supplied with. I'm pretty sure the description of new set from map will say that all the concurrency properties and so on are derived from the map that it's supplied with as a parameter.
Oh, yeah, this won't be the reason.
What this means is that there's an economy on the economization. Or whatever. It's reducing the size of the interface because this is always a problem. We aren't like the collections API is not like Eclipse collections where a different decision was made. I mean, in that case, there would be separate copies for all of the separate copies of the method for all of the different implementations. But this is a different design. There's a different design direction in which a big motivation is to keep the interface small and manageable, and it's still not small. There are very many methods on the collections.
Yeah, they already sets 10 off methods, right? For instance.
Yeah. So
we already covered the set. So what we should start with would be the collection interface itself. So there's like the base to all data structures we have? So the collections, everything implements collection interface.
No, it doesn't.
Doesn't? What not?
Well, all the maps don't interface.
Yeah.
Implement the collection interface.
You see?
There are 2 top-level interfaces.
Yeah, and the map interface is the map. So we have collection is like arrays, lists, and the map is a map. Hash maps and hash table is a map.
Collection is sets, lists, and queues.
Mhm.
So queues sit a little bit uncomfortably in the collection interface,
Mhm.
but they are there. And to start off with, it was just sets and lists.
Mhm.
And maps are maps.
This is actually, I was pretty sure, of course, but I thought no, collection is the base of everything. And good that we talk on the podcast, which I will, of course, cut out, which is not true. But so the collection interface, so the sets and queues are collection instances as well as lists, but not maps. So and the lists are ordered, but not necessarily sorted, because there's difference. Ordering is like the ordering how you put them, and sorting means, okay, I have some algorithm which reorders the list to my wishes, right?
Yeah, we sometimes call this externally ordered and internally ordered. So
Okay.
internally ordered ones are, for example, navigable set and
Mhm.
navigable navigable map, in which the elements are ordered according to some algorithm which is depends on the values of the elements. Whereas
Mhm.
externally ordered things are things like lists, where
Mhm.
it just depends on which order you've added them,
Mhm.
and you can manipulate the order.
And set are not internally ordered, and therefore, except navigable sets. But if you just consider, the set interface,
They're simply not ordered.
yeah, and it means external ordering doesn't make any sense because it would get lost immediately.
Yes. Yeah. Well, yes. Yes, it's meaningless.
Yeah, very good. And queues are special. So queue is more like,
Yeah. Queues are special. They're a kind of not entirely comfortable addition to the collection interface, and they were sort of retrofitted so that they would fit the collection interface. And some of the operations, for example, iteration over
Mhm.
queues, don't always make a lot of sense.
Mhm.
Because a queue is a structure that's actually designed for you to add elements to the tail and take them from the head,
Mhm.
and so that's the primary use case for them. And so iteration over them is like looking at the internal structure and really only the head, and you're really only interested in the head and the tail. And nearly all the implementations of queue are concurrent.
Okay, because in the queue,
That's where the emphasis is.
if I would iterate over a queue, then behind the scenes I will have actually only call the head method, but this will change, the state. So the iterator will have, to call head without manipulating the state, because you only iterate. It's like peeking into the queue, right? Peek would be
Yeah,
a better name.
it's well, yes, except that it implements the collection interface.
Yeah.
So all of the operations of collection have to be implemented by queues, but sometimes it's uncomfortable. I mean, the
Yeah, it is, because if I would be a queue designer, so I actually only thinking about head and tail, and iterator force me to provide a kind of a state to iterate over the entire queue without manipulating the contents, right?
Yes, that's right, and so it's not something you generally want to do, and therefore the queue designers generally don't give it a lot of emphasis. I mean,
So the collection
they have
interface is too broad for a queue, right? The
pardon?
collection interface is too broad for a queue.
It is. Yes,
That's
it's
the
not.
problem.
Yes. Well, yeah, but I mean, but we often find that. I mean, that takes us into the whole area where the collection interface is too broad for many things,
Mhm.
but it's too broad for many things in a different way. For example, if you take the set of elements of if you form a set, no, if you get a view, let's say if you get a view of a map, which is say the key set,
Mhm.
something like that, the
Mhm.
collection interface is too broad for that, because the collection interface allows you to add an element to a
Mhm.
set.
Mhm.
Now, the key, you can't just add an element to the key set of a map.
Mhm.
It makes sense to do that unless you're prepared to add a corresponding value as
Mhm.
well. So what will happen is if you've got this view of a map that is the key set, then trying to add something to it will give you an unsupported operation exception.
Mhm.
So
Even
unsupported.
if the map would implement, how to call it, the calculate if not exists. So if I would provide that, I will still get the because then I could generate the value from the key, right? You know what I mean?
I do, but you'd have to have a custom implementation of a
Yeah.
map
Mhm.
map to do
You're
that.
right.
That's not built into the.
But they could do this, right? They can look whether there is
Oh yeah,
provided an lambda that generates the value if the key is present. That's called calculate if not exists, I
sure,
think, right?
sure. What you could do would be you could inherit from abstract set,
Hmm.
and then you could override an abstract and sorry, from abstract map. You could inherit from abstract map, and then you could implement an inner class of your um, of your implementation, which would be the key set,
Hmm.
uh, effectively the key set class, and
Hmm.
then you could implement the add operation.
Compute if absent. This is this, not calculate. Compute if absent. This is the method. Yeah. Hmm.
Yeah. So yeah, yes, that's definitely doable.
Hmm.
But you would
Just hypothetically, just interesting discussion. So I talk with you, and just got immediately new ideas.
sure. No, absolutely, you can do that, but you can't. But you can't do it with the built-in,
Hmm.
um, um, with the supplied
Hmm.
maps in the collections framework.
Hmm. So I just think about the queues because I have a queues from the enterprise space. I use them all the time. But from the what would be a like typical use case for queues?
Typical use case for queues is in something like a workflow scenario where you've got a number of processes, which it's a consumer producer consumer scenario. So you've got a process which is producing, and it wants to pass the
Hmm.
results of its production to another process
Hmm.
or a thread. It could be a thread pool, say, that is going to consume them. So, so typically they're going to be operating at different speeds, and
Hmm.
they may well have spikes
Hmm.
in their production and in their speed, and you want to buffer them.
Hmm.
You want to
Like
buffer.
in memory executor framework, right? So this is in memory because this is in memory. And are you aware of the work stealing and hash and fork join? So this could be one possible usage of queue.
Well, for work stealing, a queue on its own isn't quite good enough. But there's a sub interface of queue called deck, which is
Uh-huh.
double
Hmm.
ended queue. For work
Hmm.
stealing, threads have to be able to take elements from the back from
Hmm.
the tail of a queue. Well, you can't do that with the standard queue interface.
Hmm.
But extended to double-ended queues, they're symmetric, and you can
Hmm.
add or remove elements from either end of a
Hmm.
deck.
This means we could implement fork join by ourselves. We
Mhm.
generate work, put it to a deck, double-ended queue,
Yeah.
and then if there are threads and they have nothing to do, they can steal from each other the work in order to spread evenly, the workload, right?
Yeah, that was the primary motivation for introducing
Oh,
deck
really? Okay,
to the collections framework.
they knew
That's
that. Uh-huh.
that's the primary use case for them. They're useful for other things as well, of course,
Hmm.
but that was what made them wanted, if you like.
Hmm. Okay, that's cool. I actually forgot also about the decks, double-ended queues, and you are right. This is yeah. You also mentioned a priority queue and concurrent linked queue. So we have another concurrent data structure, which means we can use or access them from multiple threads, right?
Yeah, nearly all of the queues. I mean, if you look at the class diagram, you can see that the primary motivation for creating queues was in fact this workflow scenario that I'm talking about, the producer
Hmm.
consumer thing, because they're nearly all of them implementations of blocking queue.
Hmm.
And the idea of that, of course, is that processes can it can be throttled
Hmm.
if for example a downstream consumer isn't consuming elements fast enough. An upstream consumer can be prevented from adding more elements to the buffer
Hmm.
if it's a bounded queue, because
Hmm.
it can block. and the downstream one similarly can block when the queue is empty.
Mhm.
So nearly all, but not all, but nearly all of them are concurrent blocked queues for exactly this
Mhm.
this situation.
You also described the DQ in the queues chapter, just for the listeners. So they have absolutely to buy your book, to understand more.
They have absolutely to buy my book, and I want to get this, and I want to get in a plug here. They absolutely have to buy my book and give an honest review on Amazon as well, because currently there's one review of the book on Amazon which gives it 2 stars but makes no comments at all. So I would really like.
It wasn't me. It's not. It is not because of the damaged packaging. Not the thing. This is like the most in such reviews. The package was damaged. The book is nothing. Just 1 star. Yeah.
I have to say, I thought this was a pretty cheap shot. I mean, if people genuinely don't like it, then obviously they're entitled to give a 2-star review. But to give a 2-star review without any explanation of why seems to me a bit low. So
and so it means to our listeners, they should get an honest review. Everything is allowed, but it should be 5 stars, right? So this is this is actually what we would like to have, and if they have 4 stars, then we have already talked, right? They should go to your talk on DevOps and ask you questions, and then after the consultations, 5 stars again. This should be it should be more popular than Harry Potter.
Thank you. Absolutely more popular than Harry Potter, definitely higher.
But there are no cues, nothing in Harry Potter. There's just empty information. But in this book, we already have we only talk about one subchapter, and we had already lots of fun. What's interests me, the transfer queue is interesting one, right?
Please don't ask me about the transfer.
Okay, then we can move on to something else.
Yeah. So some of these, definitely, some of these operations are pretty mysterious and not greatly used. I can't say I bottomed out my understanding of transfer queue in writing.
So we have to ask Stuart next time, right? So what was?
I think you have to ask Doug Lee. A great deal of the input to the
okay
comes from Doug Lee.
Mm-hmm. Okay, so anything interesting to the collection-based interface? Any interesting, I don't know, thoughts on collection, or is just like it is? So if I tell you collections, what are you thinking about? Is like this is interesting, well designed, or whatever.
Well, I do think it's well designed. I mean, overall, I mean,
design is, of course, I really admire the design of Java. If you take a look at even the early JDK classes, it's still remarkable how well designed everything else is, because I mean it's a lots of stuff and still consistent. Of course, you can always criticize whatever but 30 years old programming language, and if you take a look at the API, I'm still impressed by the quality and the quality of documentation, I have to say.
Yeah, I mean, I did want to write an honest review, an honest design review of the collections framework for the new book, and I was collaborating primarily with Stuart,
Mm-hmm.
and of course, as a maintainer of the collections framework, he's biased, and he gets a lot of criticism, which is often very poorly founded, and so he can be a bit defensive about it. And I really did not want to be defensive in the same way. I don't work for Oracle, and I have absolutely no axe to grind, as we say. So I wanted to give an honest review, and I hope that we achieved that. But what is really quite surprising about it is that the collections framework, which was produced under time pressure, designed under time pressure by Josh Bloch 30 years ago, has held up remarkably well, I think.
Yeah.
I mean, there still are valid criticisms of it, and there were mistakes that were quite clearly made. But to my mind, it's extraordinary. I mean, there have been billions of lines of Java code. Written. I mean, millions of Java programmers have used this, and it stood up, I think, really very well under the circumstances.
Yeah. That's really true.
It's a great achievement.
Yeah, and we can still learn from it. I mean, this is really great achievement, and I'm also a developer, right? And what happens to me, if I know about arrays, sometimes I write an app or whatever, and then 2 weeks later I say, okay, it was a bad idea. No, we can do better. And this is impossible in such APIs. So this is remarkable, because it is you cannot iterate. What I can absolutely. So my approach is completely different. I write the simplest possible thing, and then think about this and improve it over time, which is impossible in the APIs. So this is complete different approach.
Imagine how Josh must have felt in 1996 or 97 when he's designing this, and he's thinking Java's really going to take off. There are going to be millions of Java programmers writing this for the next 30 years, and every single thing that I do now is going to be used so many times. I would just find that so intimidating. I mean,
Java was huge. Everything was Java. Everything was Java. Everything was Java back then. It's not like it was huge. There was Java 1 2000. There were like more than 30,000 developers, and it is like it incredible time. So you cannot compare it with anything we have right now. Maybe a little bit the AI revolution. I mean, this is the similar vibe. But back then, I remember everyone wanted to have a Java somewhere, on the title J or whatever, because if you knew Java, there was a thing back then.
Yeah.
So I think just a warning, I will have to reinvite you back to talk about best practices collections a little bit. So between how to use them, just about guidance of using the Java collection framework, for instance, just to know. Because I have some thoughts. I use also collections. Just a freestyle discussion about what's your thinking, what's my thinking. It will be an interesting one. So I also would like to learn from you again, and let's see whether we can. I don't know which book is more popular than Harry Potter, but something, we can. If you overtake Harry Potter, then the next one, and the maps interface, right? So the maps interface. What I learned today is obvious, but maps is the base of all map-like structures. And is there anything interesting? I mean, the first interesting thing, of course, is less obvious, is the factory methods, like the Map.of, which is a kind of strange if you think about it, how it's implemented, but it works remarkably well, right? Because this is basically an array, but or varargs, but it works great, I have to say, right? But it's only limited to 10 elements, yeah.
Well, yes, absolutely. I mean, it's clearly an optimization on the kind of general idea of a hash structure, because if we know that there's only going to be a certain number of elements and they're never going to be changed, which is what we know about unmodifiable maps, then there are a whole lot of simplifying assumptions to the implementation. They're going to be a lot more efficient, that's for sure, both in space and in time.
And what happens to me frequently is recent years, I always hit the limit of 10 elements in Map.of. So I use it 10 times, and the 11th times I get a compiler error. So why that? What's wrong? And I hit the limit, because what I use the map is for infrastructure as code. Let's say account management. So I have infrastructural accounts, account IDs. On the right side is a record or an enum with the actual account data. And sometimes there are more than 10 accounts. So I get surprised, okay, wow, why it doesn't work? And then I use entry set, which is a nice hack. You can do the same with entry set. It's very similar. So you can create entries, and then you can have as many as you like. But they are, I would say, a great pragmatic additions to Java recent years. And anything special, or what do you say about the map interface? What comes to mind? Is my nothing to say? It's just a base interface, or maybe something interesting?
No, I don't think. I don't see that as so problematic. I mean, I guess the most interesting thing about it is, did you really want to make maps? I mean, the mistake that you made there of thinking about thinking about collections being the top level interface is entirely understandable, because it's perfectly reasonable to view a map as a collection of key value pairs.
Maybe because for me, collections, it sounds like, collection of, it could be a map. For me, mental model, map is a collection because it collects things differently. Maybe it should be like, not collection, maybe not a list. I don't know how to call it. It's like, collection, if we put it this way, is more like a sequence of something, right? So like a sequence or single level, maybe. And map is a collection of pairs, right?
Yes, it's a collection of pairs.
Absolutely. A collection of pairs. This would be this is actually the yeah.
Yeah. So it would have been possible to actually to design a type hierarchy in which map is a collection of pairs. And in fact, mathematically, that's exactly how maps are defined, because everything is a set in set theory, and that's exactly how a map is defined.
Ah, you said everything is a set in. Okay,
a set of pairs.
In set theory, but there should be another theory. Otherwise, it wouldn't be possible to have a list with duplicates, right? In math,
A list with duplicates.
yes.
You can't have so you can't have duplicate keys, and so that's
In list, not in map. Just forget about maps. Go list. So in list, I can have duplicates.
How could you base it? Well, so the way that you would base, mathematically,
Yeah.
we're never going to do this in real life, but mathematically, you would base a list on being a map from natural numbers to the elements. So from the index to the elements.
Yeah, but you said in math you can absolutely have duplicates, but in math we could have duplicates, but the not in the set theory, right? So there should be another theory which backs the lists, but not sets.
No, if you're going to allow maps, then lists can fall out quite easily, including duplicates.
No, and just forget maps. What we focus was sets, and there is the set.
Maps can be based on sets.
Yeah, but
everything can be based on sets in the end.
But no, we discussed the set chapter, right? Set chapter, and we mentioned the theorems or the axioms not from the piano, the other guy. Who was it?
The Zermelo-Fraenkel.
Exactly. And we focus on the sets. And now my thinking is, just so we have sets, and there's a mathematical theory behind that.
Yeah.
But what about lists? Because if you have a list, you have a duplicates. It doesn't fit the set theory. Is the other theory which deals with duplicates and lists, not maps, just lists.
No. It would be the same theory, except you're going to allow maps. First of all, you have to allow maps. Then lists
to have duplicates. To have
duplicates in a list, you're going to allow to have maps. So maps are a kind of set. They're a set of pairs. And now a list is a map from index to value. So the first element of the list, the zeroth element in Java is going to be the value that corresponds to the key 0. And the second element is going to be the value that corresponds to the key 1, and so on. So that's how you're going to base a list on a map and eventually on a set.
Okay, so in order to have
do this in real life, obviously.
No, but from mathematical perspective, in order to have duplicates in a set, you will have to use map.
Yes.
From the mathematical perspective, there is no other way to define a set with duplicates, which is a list. You will have to use a pair.
You're going to have to use some disambiguating value. You're going to have to associate the duplicate elements with something that isn't duplicate.
And is there a concept in math like how it's called? Reference holder or reference, not reference. There is atomic reference. Like a wrapper.
You like a wrapper.
You could have a wrapper in math that you say all wrappers are distinct, but they point to the same value.
Yeah, absolutely, you can do this. So this is how the classic Bertrand Russell's theory of numbers. He wrote the fundamental Russell book. Constructs numbers out of set theory, and it takes many pages. It's kind of legendary about the it's legendary how many pages he takes to get to a definition of addition. I'm trying I'm now trying to remember this. Principia Mathematica. That's right. So in Principia Mathematica, um, it's like many chapters in just to get to how we define addition. But it's the idea of Principia Mathematica is it bases everything in the end on sets,
Mhm.
and it's completely impractical. Obviously.
Okay, so you can pick a set and then define a list with duplicates just on sets with. But it just interests me, because a set is obvious, and then I thought, okay, what about lists? And of course, maps are also based on sets mathematically because the keys are like a set and the value is just a mapping. So I understand that, but I was just curious because this list of with duplicates
Right.
is mathematically not very pure, right? Because it's like there are multiple things in one bag, and now I understand it. Okay, so maps. Sorry for the confusions, but this is how always works with you provide me something is a great idea. It's like, cool. What about that? Now I take the time and ask you about things, and so there are one really interesting implementations which is available in JavaScript for a few months or recently was added. Weak hash map, which has actually solved a lot of problems in user interfaces. Because before weak hash maps, we had a problem that you had a button in JFrame in a window, and if you had the listener, it was a hard reference, right? So if you closed the window, it was not really garbage collected because the listener was still there. And the weak hash map or weak references are an easy way to maintain such things. So what means is if this is the last reference, it is going to be garbage collected, right? So which is incredible, actually.
Yeah, well, it depends. It depends on having this idea of a weak reference. I mean,
Mm-hmm.
that's it's not the implementation is not that complicated once you've decided to have a weak reference, which clearly puts makes a lot of demands on the garbage collector. This is a kind of major implementation requirement on the garbage collector. So the garbage collector has to recognize objects that are objects that are no longer referenced, and then it has to add them to a queue that are going to be garbage collected after a sweep has been done. So then to use one of these holders that you're talking about, a weak reference, which is an object that simply encapsulates a reference and allows it to be broken by the garbage collector if it's no longer required. That it's relatively straightforward to put that into a hash map.
But still useful data structure because it comes out of the box. You can just use it, right?
Yeah. No. Well, I'm interested to know. I mean, sometimes a weak hash map is criticized because the weak reference is on the key, which is not completely obvious that it shouldn't be on the value instead. So people sometimes criticize that. But if you found it useful, then I'm happy to hear that.
Yeah, I found this useful, and I found useful what I used is the weak references a lot back then. Now a little bit less because the servers became simpler. Back then they were long-lived, and we referenced the references a bit more. And now sometimes I even disable the garbage collector because I know the server will survive maybe 2 minutes and then it's gone. So who cares about garbage collection, right? So this is interesting,
Right. That is interesting.
Yeah. The how it's called zero GC, the one not zero GC. What the garbage collector which doesn't do anything. This one is zero GC, I think.
No, I don't.
There's a garbage collector which if you configure this, it does nothing, so it doesn't collect any garbage. It is used actually for tests, but it's very useful for in sometimes if you have short-lived servers. So it's like why they should collect garbage. We have enough memory; they will survive 3 minutes, and then who cares, right? So
Right.
okay,
so there's an epsilon garbage collector.
Exactly.
That's the one.
That's the one, not zero. Exactly, this one. The zero GC is actually useful one. I confused that. This is the and.
Okay. How long? I wasn't aware of the epsilon garbage collector. How long has that been around? It doesn't
I would
say.
say 2-3 years at least. So because I know use it for longer, but yeah. And the ZGC is very very useful actually. This is also the generational ZGC, and I use it a lot in normal projects. Another interesting, maybe two more implementations of HashMap, identity HashMap. Why we need identity HashMap?
You need identity hash map when what you care about is not it's another example of a map whose keys form a set with a different equivalence relation. The
Mhm,
equivalence relation on identity hash map is not equality, which is what the set specification says should always be used. But as I've already mentioned, it's not used by navigable set,
mhm,
which uses the comparators algorithm. In this case, identity hash map uses the uses the actual identity.
mhm.
So
Also equals equals.
two elements are only equal if they're the same element as
Mhm.
far as identity hash map.
Equals equals, right? Equals
Yeah,
equals.
equals
Yeah.
equal. Yeah,
Mhm,
absolutely. So this is useful if, for example, you want to do. I mean, it's used in serialization, for instance. If what you want to do is to um, explore an object, explore a graph, an object graph,
mhm, mhm,
but you don't want to get into infinite cycles. So you want to be able to say you want to be able to say, I'm going to serialize this thing, and in order to do that, I've got to serialize this thing, which is a component of it, and serialize this other thing, which is a component of that. And if you happen to come back to your original thing, you want to be certain that you don't start again and go round
Oh
again.
yeah. Oh yeah.
So instead of checking whether or not each element is equal to one that you've seen before,
Mhm,
you check whether it's the same as one that you've seen before. So
mhm,
you ask, does the key set for this identity hash map contain this object that I'm now looking at?
mhm,
And you won't get equality. You'll get that only to be the same if it is actually the same object. And then you say,
mhm,
okay, now it's time to stop because
mhm,
I've explored this cycle far enough.
mhm. Um, I tell you about actually a nice hack, which is extremely dangerous, but it worked well. And so, how many years ago? A long time ago. I had to perform some optimizations in project which use a lot of XML,
Mhm.
and XML are basically strings. So they had a lot of strings comparisons, and the problem is if you compare to strings, so they are compared, character by character.
Yeah.
If you have lots of them, it's slow. And what we used that in crucial parts, we called String.intern,
Right.
which is a flyweight pattern. So it means the strings were kept in one memory,
Yep.
and then we could use equals equals for
Yep.
string comparison,
Yep.
which was extremely fast but very dangerous because if someone forgot to call String.intern, you were never sure whether it worked or not.
Right.
But this was actually stellar because I don't know how fast it was, but it was orders of magnitude. It was
Oh yeah.
terrible hacked, but it worked perfectly.
Well, it would be because all you have to do is just hash the string value once.
Yeah.
Yeah.
Yeah, everyone called me crazy back then, but you say, of course. So this is a good sign, actually. After years, I can talk about such things because, it is already expired. The warranty. uh, Very good. And another, maybe the last one, is enum map. Why we need that?
Enum map. Well, so the idea of enum map is that you can depend on
Page 261.
page 261. So I have an idea in my mind about this. Let me
I
see.
use it recently, but I'm actually curious what you say about it.
As to why we have it. Well, the reason that we have it is because there's this really really optimal implementation using a
Mhm,
bitmap.
mhm.
So so the so an enum map, the keys are simply
Like enum set, but there's a map.
yeah. Well, it's the same reason. So if you think about with an enum set,
Mhm,
you can represent that by a bitmap.
mhm,
It's simply because you know in advance all the possible keys there can be, and you have an ordering relation on them. You can simply represent them by the bits in a word. Or there's two implementations of enum set. One of them is for small ones, which will fit
Mm-hmm.
within a 32-bit or
Mm-hmm.
64-bit
Mm-hmm.
word. I can't remember which. And then one which is a jumbo. That's right, a jumbo enum set. That's
Mm-hmm.
an inner. That's a package private class.
Mm-hmm.
You don't see the difference between those when you form it, because of course when you form an enum set, you already know how many elements there are
Mm-hmm.
to the enum, so you know whether to choose an ordinary implementation or a jumbo one.
Mm-hmm.
So an enum map just gets the same efficiency because the
Mm-hmm.
keys are simply you're mapping simply from the bits
Mm-hmm.
of a word or
Just performance reasons, right?
it's performance reasons,
Mm-hmm.
absolutely performance reasons. Also, you can also get more sharper typing, more precise typing
Mm-hmm.
because you know the type of
Mm-hmm.
the enum.
Mm-hmm.
So yeah, there's advantages in that as well.
Maybe the last unrelated question to collections rather than to enums is I used enums a lot, also for configuration purposes recently, and I don't like the idea that name is final, the method name,
Uh,
because the name. So enum ships with a name method, right?
Yeah, yeah.
And I think it would be better if this method wouldn't be final, because what happens to me a lot. Also, I find enums really useful, and what I do with them is I define a constant. Let's say read file, um, and then I need a different representation of the constant, like a read file with in camel case, read file lowercase, and whatever. And sometimes there's only one. And what I would like to do is, for instance, if I would call name, that it, for instance, that I can change, the convention. So I will derive, the to give you an example. This is but infrastructure as code in the clouds, for instance. So I have, let's say, a name which represents an infrastructure part, like let's say load balancer. And the load balancer, I would like to have it's like a variable name, and one is like constant name, and the same load balancer appears in configuration multiple times, once as a key, then as a value, and so forth. So I need various representations of the same constant. And what I do sometimes, if there's one-to-one mapping, I skip the conventions and I name the constants in enum, like read file. I would call it just lowercase read and f big. So that doesn't look like an enum, but I don't have to provide any mapping. And I could provide the mapping in a constructor. But if I call name, I still get the name. So I have to ask Stuart in on occasion. So why the name is final? Because why? I mean, this is my choice if I override the name, right? But no, there's nothing about collections. It's just we
No,
talk about enums, and I was just
I'm just trying to think. I don't suppose there's any kind of overriding reason as to why you can't do that. I think it's just my immediate reaction. I have to think about that, but my immediate reaction is to think, well, it's just kind of an unusual use case, and
yes,
for the most part,
yes,
people want and for the reduction of complexity, like you just don't always get unusual use cases catered for
yeah,
because
but but
it complicates the API.
but before enums, it creeped in. So before enums, I defined all the constants on an interface, right?
Yeah,
So and then enums came, and it's okay. So we can have all the constants from interface in an enum, and they are basically a set. So we can iterate over them and do something useful. And
yeah,
then already starts, because what you could do is you could, for instance, pick the enum constants and automatically transform them to dot notations for Java util properties. So we have the first use case where you have maybe a capital file underscore read to lowercase file dot read. So the first transformation.
right.
And but the dot is not usable as a Java variable. So I would like to transform the read underscore file into camel case read file. So I have two transformations from the constant name, and I cannot use name. I provided my own methods. This is not the end of the world. But I find surprising how many use cases for enums I recently found in the last 2 years, and I do more and more with them. And what I also found, which also surprised me, the similarity between enums and Java records.
Well, why don't you simply add a new method to
This is what I do.
Yeah.
This is what I do. But for simple mappings, I actually recorded some shorts recently, and I got also comments because I said, okay, sometimes I have an enum operation. This was the example from my YouTube shorts operations, and the enum convention would be file capital underscore read capital, right? It would look like a constant. This is the convention. But what I would like to have is in my Java code is file lowercase camel case convention. So file read, right? So and I got a proposal from the community. Say, okay, why don't you define a default constructor or parameterless constructor, which I could do. But if I call name, I still get the capital case name. I can so I will of course then have to provide additional method. And okay, if I add additional method, I could do this, but overriding name would be nicer. But it is doable. I just thought maybe some thoughts, because it's a little bit disturbing that it's final. So I saw why, because I don't see the reason. So if it's my decision to override that, what could I break? So this is maybe there's some internal reason. So I will ask someone who would. Yeah.
I suppose.
Maybe performance reason back then, right? Because final was faster. Because this could be.
Well, final is always better from that point of view.
Yeah, exactly.
Also, from there might well be some implication in terms of.
But you know what I would like to achieve, right? This is like different mappings from the constant name to different representations. And if there's only one representations, I will misuse name. If there are multiple, I have to provide additional methods. So no problem. Yeah. But thank you. And I will reinvite you back, because a little bit more about freestyle talk about how to use collections. So what's the idea, how to start with, or whatever. Just your last chapter. And the name of the book is Java Generics and Collections: Fundamentals and Recommended Practices, by a young gentleman, 30 years old, about to retiring, Maurice Naphtalin, Philip Wadler, and Stuart Marks. Yeah. Yes, and before you order the book on Amazon, 5 stars review with a short sentence why the book is great. And if there is something less optimal, they have attend DevOps conference, attend your talk, rate the talk with 5 stars or whatever we have, 10 stars. I forgot what the ranking or rating is, and then have a chat with you why you describe it this way, right? This would be the.
I'm very happy with any honest review of the book. But I do feel that if you're going to give it 2 stars, you should have a word or two about why.
Yeah, but why not give you 5 stars? The book is great, what I can say. And then if there is something to improve, they should talk to you. And Absolutely. Then 3rd edition happens. And this is
then the 3rd edition.
Because if they rate the book with 1 star, 3rd edition won't happen, and there will be no improvement. There is no iteration, right?
Absolutely, this is absolutely true. Yeah, if you want to see a better version, you better persuade.
5 stars and email to you. If you don't like to read, no stars or do nothing, and then it will happen, right? So
absolutely.
And how people can find you on the internet?
Oh, look for my name, Maurice Naphtalin. Mm-hmm. Yeah, I mean, there aren't very many Maurice Naphtalins around, so.
You are singleton.
I'm indeed. I'm a singleton. Yeah, and I think I hope. Yeah, I mean, I've actually got a, what do you call it, a knowledge panel. Lucky me, and somewhere actually a website. So yeah, no, if you just look for Maurice Naphtalin,
yeah,
find a lot of stuff.
So yeah. You're alone. You are absolutely alone inside an identity hash map, right?
I am indeed. Yes.
Yeah.
Absolutely. Yeah.
Yeah. So thank you. I really enjoyed the conversation. So, and see you next time.
Yeah. Thank you very much, Adam. Yeah, and thanks to everyone who's listening for putting up with this.
I got already on YouTube great feedback that they really liked you.
Oh.
Yes.
I'm delighted to hear that.
Thank you.
Okay. Thanks a lot, Adam. Cheers.